right, these are the acceleration notes. So acceleration is the rate at which an object changes its velocity. If an object is speeding up or slowing down, the velocity is changing, not constant. The object is accelerating. So if you're speeding up, your velocity is going to be increasing. If you're slowing down, your velocity is going to be decreasing, as long as you're moving to the right, if you're moving in the positive direction. Constant velocity means that you don't have an acceleration. Your acceleration is 0. If your velocity is constant, there's no change in your velocity. Constant acceleration is when an object changes its velocity by the same amount each second. So you're accelerating at a constant rate. Your speed is changing at a constant rate. Acceleration is a vector quantity. So remember that vectors have magnitude and direction. So think back to our other vector quantities we've talked about. We've talked about displacement needs direction, velocity needs direction, and now acceleration also needs direction. So usually we're going to put a plus or a minus sign to indicate the direction of acceleration. The direction depends on two things: whether the object is speeding up or slowing down, whether the object is moving in the positive or negative direction. If an object is slowing down, then its acceleration is in the opposite direction of motion. So this is a little bit confusing to some people. So let's imagine that we're moving to the right. If you're moving to the right, your velocity is to the right, okay? But if your velocity is getting smaller, you're slowing down, your acceleration is actually the other way. Your acceleration is going the opposite way because it's slowing you down. So your velocity is positive. Okay, it's just getting smaller, but it's going to the right. Your acceleration would actually be negative because it would be going to the left. Your velocity is decreasing, so your acceleration is negative. For acceleration, remember that, let's remember that velocity includes direction, right? We just said that just a second ago. And a change in direction indicates that there's a change in velocity. Okay? An object moving in a circle is constantly changing direction, which means that it's constantly changing velocity, the direction of the velocity, right? And so that means you're accelerating. So this is a tricky part here. So if you're going in a circle, okay, and let's imagine that we're going in a circle. Even if the magnitude of the velocity is the same, so let's say that we were going 5 meters per second in a circle. So we were always going 5 meters per second. That's our speed. But because we're moving in a circle, we're constantly changing direction. So even though your speed is not increasing or decreasing, you still have acceleration because you're changing direction. So the formula for acceleration is the change in velocity, right here, change in velocity, that's what the triangle means, over time. So to write that down, what that means when you do the change, that triangle, it means you do your final velocity minus your initial velocity over the time it took. So you want to subtract your final and initial velocity. You always start with the final and then you subtract your initial. And the units for acceleration are meters per second squared. You have to square the seconds because velocity is already going to be in meters per second. And then you're going to divide it by time again, usually seconds. And so you end up with meters per second per second. That's the same thing as saying meters per second squared. So that's why those are the units for acceleration. And then don't forget you need a plus or a minus to indicate the direction of your acceleration. Okay, let's check our understanding here. So a cyclist accelerates from 0 meters per second to positive 10 meters per second in 5 seconds. What is his average acceleration? Remember that acceleration is your final velocity minus your initial velocity over time. Our final velocity is 10 meters per second, positive 10. That's what we got to. We started at 0. So 0 is my initial velocity. So I'm going to do 10 minus 0 divided by the time is 5 seconds, divided by 5. Well, 10 minus 0 is 10, divided by 5. 10 divided by 5 is 2. It's going to be positive 2, and it's going to be, your units for acceleration are meters per second squared. A car advertisement states that a certain car can accelerate from rest to 17 meters per second in 7 seconds. Find the car's average acceleration. So again, we're going to do final velocity minus initial velocity divided by time. So we're just going to assume that we're moving to the right to make this a positive. Okay. So we're going to do 17 minus 0 divided by 7. So that's going to be 17 divided by 7. So we're going to go ahead and type that in. And that's going to be positive 2.4. You can just round that to 1 decimal. Meters per second squared. So that is the average acceleration. So that means that each second, the velocity increases by 2.4 meters per second. A person runs around a track with a constant velocity. At what point is the person accelerating? At what point is the person not accelerating? So A is this straight stretch here. B is a straight stretch, and C is a corner. Okay, so remember that acceleration only happens when you're changing your velocity or you're changing direction. Now they're running around the track, and really this should say constant speed. They're running around the track with a constant speed. So they're not speeding up and they're not slowing down. So that means the only time that we have acceleration is when we're changing direction. And so the only time that we're changing direction is at point C. So the answer is C. And let's just review motion diagrams and talk about acceleration when we're talking about motion diagrams. So remember that a motion diagram can be formed by imagining the stroboscope photograph of a moving object, which means that you just see the object where they are each second. You don't see in between the seconds. Red arrows represent velocity and the purple arrows represent acceleration. So in the first picture here, the car moves at a constant velocity. So the car is moving at a constant velocity to the right. And you can see there that the distance in between the arrows and the sizes of the arrows is all the same. And so if you're moving at a constant velocity and they're just moving in one direction, so they're not changing direction. So at a constant velocity, they're not speeding up, they're not slowing down, you have zero acceleration. For B, the car has a constant acceleration in the direction of its velocity. So notice that the velocity arrows are getting longer. The distance between the arrows is getting longer. So the car is speeding up. It's speeding up. And that means that the acceleration is positive and is going to go in the same direction as the velocity. So positive acceleration goes in the same direction as velocity. For the last one, the car has a constant acceleration in the direction opposite its velocity. So you can see here that for the velocity, that the space between the arrows and the arrows themselves are getting smaller. So that means it's slowing down. The velocity is decreasing. And when that happens, then the acceleration points in the opposite direction. When you're slowing down, it points in the opposite direction. And so that means that you have negative acceleration. Negative acceleration. So it is slowing down. Okay? So positive acceleration, if you're speeding up, moving to the right. Negative acceleration when you're slowing down, moving to the right as well. So all of the acceleration problems that we are going to do, we are always going to assume that the object is moving to the right.